Advanced Math Lesson 77, we're talking about binomial expansion, part 1. So before we start doing binomial expansion, we have to learn something called Pascal's triangle, right? So Pascal's triangle is just a number triangle that starts with 1 at the top, and then it splits and adds an extra number every time. So the first, the top of the triangle is very important. If you don't have the very top of the triangle right, you won't get the rest right. So it starts with 1, and then the 1 splits to a 1 on the outside. Now what's going to happen every single time with this triangle, as we go to the third row, is we're going to follow some rules. The rules is that each number is going to split, all right? But we're adding numbers that combine together. So if you think about it, each number is splitting in two directions, left and right, left and right, left and right. Here, whenever two numbers point to the same location, we add them. Okay. So here I've got 1 and 1 both pointing to the central location. 1 plus 1 gives me 2. Okay. Now I'm going to do this split again. Eventually you'll get to the point to where you can do this without drawing all these little split lines. The outside is just going to be 1 and 1. And then here 1 plus 2 is 3. 2 plus 1 is 3, right? And now I'm drawing the triangle. So now I'll go ahead and I'll stop drawing the split lines, and you guys will see the trend. So the way this works is I do 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 3 is 4, and the outside is 1, right? And then I can draw the triangle some more. I've got 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and the outside is 1, right? This is Pascal's triangle. Pascal's triangle goes on infinitely, right? It's a really fun little number theory thing that you can draw. 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 1 plus 5 is 6, and 1 on the outside, right? This is Pascal's triangle. It goes on forever, infinitely. Where in the world is it useful? Well, it's very useful for binomial expansion. So binomial expansion is whenever we have something like, we'll do a plus y, and then we'll take this binomial term, we'll put it to the power of, let's do something ridiculous like 6, okay? That is annoying. You'd have to write this out 6 times, and then foil, and then foil, and then foil. There would be so many polynomials for you to multiply and add, and so many like terms. So Pascal's triangle helps us out with this. The way it helps us out is we just simply count to the 6th row. And technically Pascal's triangle starts off at 0. So the top one's always going to be 0. We got 0, 1, 2, 3, 4, 5. Hey, 6. Oh, that was an accident. Happy little accident. I actually drew out to the 6th row. So what this tells me, Pascal's triangle, is that if I have a binomial number being expanded to the 6th power, the coefficients are going to match this 6th row. So the coefficients for the terms, okay? And notice this works with positives, okay? So what's going to happen is this 6th row is now going to be part of my answer, right? So the answer will be 1 times some value of a and y, so plus 6 times another value, and then we'll say 15, right? So I'm pulling the numbers off the bottom row, and then that'll be plus 20, and then plus another 15, plus another 6, and then plus another 1. Okay. Now the question is, where did all my a's and y's go? That's incomplete. So the a's and y's are very interesting. The way this works is you're going to have to label your a's and y's, or whatever your letters are, right? This will be the first letter. This will be the second letter. And the way it works is the exponents are going to count from 6 to 0. So the first letter starting from the left. So what happens is I take the first letter, I go to the left. It's going to start off with a to the power of 6. The next one will have a to the power of 5. The next one will have a to the power of 4. Then a to the power of 3. Then a to the power of 2. A to the power of 1. And the last one will have a to the power of 0, but I don't have to write that. Okay? So the first term starts from the left, counts from 6 down. And the second term, we'll call it y, the second term, counts from the right, 6 down. So on the right, all the way on the far right, I'm going to have y to the power of 6, and then here I have y to the power of 5, and y to the power of 4, y to the power of 3, y to the power of 2, y to the power of 1, and then no y. And this is my answer. This is the answer to a plus y to the power of 6. So that's binomial expansion. It's not very difficult. You just build Pascal's triangle however far you need to, based on whatever exponent you have, and then you can create the entire polynomial expansion. Now, every now and again, they won't ask you to recreate all of this. They'll just ask you for, like, oh, what's the fifth term? If they ask you for the fifth term in this expansion, that's very easy. Here's 1, 2, 3, 4, 5. This is the fifth term. That's my answer. Okay? That's it for this lesson. If you guys have any questions, let me know on the school website, and I will see you in class.